Unit 2, Practice 3, I can identify a function and its domain. A function is a line that goes from left to right. Just like we read sentences and words from left to right, we also read graphs from left to right. So if we look at this, we can say we start at the left, we go to the right, it never changes direction. Not direction, it doesn't start to go backwards. It doesn't go in the opposite direction. It doesn't move from right to left. Here we can see it goes from left to right. Here we can see it goes left. And we still keep moving to the right. Even though we changed direction, we went down, up, down, we still kept moving from left to right. Another way to look at a graph of a function and know that it is a function is it's going to pass the vertical line test. And what that means is if we draw a vertical line or a line that goes up and down, we will only cross through that graph at any point one time. So I can draw as many vertical lines as I want, but that vertical line is only going to touch that graph one time. Now here are some examples of non-functions. If we look here, it goes from left to right, but then it moves from right to left. It starts going backwards. Also, if we draw that vertical line up and down, you can see that it goes through the graph more than one time. It goes through twice. It touches twice. Same with this here. It goes from left to right, and then it starts going from right to left. So, and also, if we draw that vertical line here, you can see it goes through 1, 2, 3 times. So it does not pass the vertical line test, so it's not a function. Now, if you're given a table instead of a graph to identify if it's a function or not, we're going to look at the x values. Each x value must have one and only one corresponding y value. So if we look here, we have 1 goes to 4, 2 goes to 8, 3 goes to 11, so on and so forth, and we have no repeats, no repeated x values. That means each one only has one corresponding y value. So that makes this a function. Now, the opposite of that would be this graph. You can see how we have x is 1, y is 4, but then if I come down here, I also have x is 1 going to 5, which means 1 doesn't have just one y value, it has two y values, which makes this not a function. We can see we have two repeated x values. 1 is repeated as well as 2. So when you have those repeated x values in a table, that's going to make it not a function, and because the graph is not going to be passing that vertical line test. Now the domain of a function is the possible x values, so the values we can put in for x. Domain of a function we are going to write as an inequality statement. So if we look here, we have our domain of this piece of our graph. So if we look at for x values, we're going to look at our horizontal axis, our x-axis, and we're going to see what numbers we line up with. We line up with -2 for one of our values. This will be our lowest value, so I'm going to put that to the left of our x. And then we also line up with 4. This dot is on that 4 line on our x-axis, so we're going to put 4 for that biggest value. Now that we have our numbers, we are going to write this as a between inequality. So we're going to always use less than inequalities, and this just says that x is between -2 and 4. And since this has closed circles, that means we can include -2 and 4 in our domain. So we're going to put lines underneath our inequalities. And that inequality symbol is less than or equal to. So now if we look at our next graph, we can see it looks a little different because we have these open circles here. That means we're not going to include those values that we're on. So if we look at our x-axis and we find what values we line up with, we can see we line up with -6 as our smaller value and 5 as our bigger value. Now we're always going to read from left to right, which means we always want to put our numbers in order from left to right. So we're going to start with the smallest number, that number on the left, and work our way to the bigger number, the number on the right. And then we are just going to use two less than symbols. So -6 is less than x, which is less than 5. That's how we can read that. Or we can say that x is between -6 and 5. And in this case, we're not going to include the line underneath it because these are open circles, so it's just that less than value. Two more examples for you. We have another graph to identify the domain of. So if we look, we can see a closed circle here and an open circle here. That means for this number right here, for this -2, we're going to have that less than or equal to symbol next to the -2 because the circle is closed. And then for our next value, we have +2. And we're just going to have a less than symbol next to that one because the circle is open. We cannot include 2 in our answer set. Now, if we look at this next graph, it looks a little different. There's no circles on it. There's just arrows on the end. Those arrows indicate that that line continues to go and go and go and go forever in each direction. So in this case, our domain is all real numbers. That's saying we could plug in any number for x. It doesn't matter. 1,000, -12, you could put in any number for x and it would still remain a function. Any number would work. So when you see that, that's just a domain of all real numbers. All right, that is all of your notes for today. You are free to do your classwork. Make sure you answer all of the questions on the following slides or in the paper packet, and then take your check-in quiz at the end.